results. Now we'll move towards the module 7. In the module 7, the results will be checked after the analysis, and we will check the drift as per the code and then torsion irregularity as per UBC 97. And the let us I have run the software, the model already, because it will take some time. So to save the time, let me display deformed shape. Go to the elevation. You can check the deformed shape of your structure for the different cases. For example, for the earthquake, you can check the deformed shape of your system. Take it as a maximum. You can give your own scale factor, and you can run the animation as well. If I run the animation, so you can check the deformed shape for the different load case. For example, for the dead, you can check the deformed shape of your building. For the different load combos, you can check the deformed shape of the different structural members, for the beams, for the slabs. You can check the bending moments as well for the different load cases. So these are the bending moments in the beams. This is the shear 2 in the beams. For the combo 2, you can check it for the with the combination of the seismic. You can see it has been increased with some factor. If I go to the 3D, you can check it out the value by right clicking on one of the beam. For example, this one, right click, and you can see the detail, what is the maximum shear, what is the location, and what is the bending moment, and what are the different values for the bending. It is negative, but it is positive. And these are the different cases. You can check the you can also check the deflection of the beam on the gravity loads. You can check the deformed shape by going to the display and click on the story response plots, and you can check the maximum displacement for the building in the x direction, in the y direction, and you can select the case or combination as well. For example, the maximum story displacement for the direction earthquake x is 1.6 at the 11th story, which is the overhead tank, which we do not consider in calculation of the drift and torsion irregularity. You can check the story shears as well for the earthquake in x direction. These are the different story shears, and you can see that the value changes when you change the load case, display type, for example, the shears, and you can check the story stiffnesses. You can check the maximum story, diaphragm drifts, outlet or loads that has been applied to the diaphragms. You can check it out these values in the story references. The next important thing is the checking of the drift as per the code. So drift are limited with some values, and the drift limitation in the building code of Pakistan or the UBC 97 is written as that the story drift shall be calculated using the maximum inelastic response displacement delta m. The delta that you are getting, for example, the displacement in here. This is the displacement, maximum story displacement. The displacement in here, for example, 1.8 inches. This displacement is actually delta S, which is the elastic displacement. But the code says that when you are calculating the drift, you must use the delta M. And for the calculation of delta M shall not exceed 0.25 times the story heights of the structure, having fundamental time period of less than 0.7. And for a structure having fundamental time period of zero point 0.7 second or greater, the calculated drift story drift shall not exceed zero point 0.2 times the story height. So understanding the code language is a bit difficult. So I have made it very simple. For the drift calculation using delta M calculated into which is the zero point 0.7 into R into delta S. Delta L is the displacement from the etabs, and, and the limitation for the drift is 2%, which is 0.2, and this is for the building which have the time period greater than zero point 0.7. For the fundamental time period less than zero point 0.7, the limitation of the drift is 2.5%, and the delta M is calculated as the same. So in etabs, the following path can be followed to find the different parameters that can be used to calculate the drift limits. Then you have to go to the display and click on the show tables and results, and click on the story maximum and average displacement. So insert these values in the Excel sheet, which I'm going to open it. If there is no drift issue, you can move out with the design, and if there is a drift issue, you can provide the shear walls, and then you have to decide in which direction to control the drift. So first we will check the fundamental time period, and we can check by going to the display, click on the deform shape, and we will select mode, and the first mode is actually the fundamental mode of the building, and we will click on apply, and you can see on the top 3D view mode shape model mode 1 period is 1.446 seconds, which is greater than zero point 0.7. So for our building the limit for the drift is 2%. Next, we will go to the display, show tables, click on the analysis, results, and click on the displacements. And click on the story maximum average displacement, and filter this load combo for the earthquake in the X direction first. Right click on this tab and select only earthquake X, and you can see the direction is X, and there is a maximum and average displacements. So you have to copy these values. Let me show the sheet first. So this is the Excel sheet we are going to use. That for the delta M, the fundamental time period for our building is actually 1.5. So the drift limit is 2. If it is, for example, 0.4, the drift limit becomes 2.5. So we'll take it 0.449. So the drift limit in our case is 2%. And these are the uh, data input uh, tables that you have to insert the story elevations in feet in here, the R value, response modification, and this is the delta S from the E tab, and this is the delta S for the in Y direction from the E tab. It will calculate delta M, and from the delta M it will calculate the story drift in the X direction and story drift in the Y direction. Story drift is actually the uh, this is the formula which we have inserted. This is the displacement by the story difference of the story below, and then you have to multiply with the 100. You will get the story drift in percentage. So these are the story levels. We have 10-story building, and these are the story elevation. You can get the story elevation information by going to right click on the add modify grid, click on the modify show story data, and these are the story elevation. You have to click on these and copy these and insert these values in the Excel sheet. The next one is the R value, which we have used in the design. You already know if the R is 8, R is 7, R is 5, you have to insert that as well. And then you have to insert the delta S from the x direction, delta y from the, let me make it all 0. You can see the drift is become 0, and we will go to the E tab, and we will select the average and maximum, only the maximum value for 10 story. 11 story is actually the overhead water tank, and click on the copy and insert these values in here. You can see that the drift is within the limit. It is, you can see it is increasing when you go up. It is 0.1%, 0.5, and it is maximum value is 0.6% at the story of 5 story. The next is the right click and click on the tab in the earthquake in the y direction, and copy the maximum value for the displacement in the y direction, and insert in the delta S y. And you can see that the drift in the y direction has been calculated, and the maximum is 0.97 again in the fifth story. So if the value is not within the range, it will, the cells will become red. For example, let me make it 2. So 2 is very high. Let's make 1.7, 1.8. So you can see that the value is greater than 2. So it will become the cell will become red. It means that the limit is 2 and the drift is 2.26. Then you have to repeat your analysis or insert the shear walls to incorporate or make it 2% in your building. So let us go to the E tab, and let me show you, for example, if there is an issue in the X direction. For example, there is an issue in the X direction for the drift, then you have to insert the shear walls. Let me click on this. Then you have to insert the shear walls parallel to that direction. For example, this is the X direction, then you have to insert the shear walls parallel to that direction. So this is the way you can reduce the drift in the building. If the drift issue is in the Y direction, then we have to insert the shear walls parallel to Y direction, like this. And then you have to check again, do the analysis, and when it becomes 2%, so that is fine, right? The next is the torsion irregularity check as per the code, and it is given in the table 5.12 that the torsion irregularity to be considered when the diaphragms are not flexible. It means when they are rigid. When the diaphragms are semi-rigid, then there is no need to check the torsion irregularity in your building. So it says that the torsion irregularity shall be considered to exist when the maximum story drift computed in the including accidental torsion at one end of the structure transverse to an axis is more than 1.2 times the average of the story drift of the two ends of the structure. So again, understanding the code language is a bit difficult, so you have to read it out very carefully. So from the above statement, we have concluded that delta maximum divided by delta average, this ratio should be equal to or less than, it should be less than 1.2. So then there is no irregularity in your building. If this ratio is greater than or equal to 1.2, so there is torsion irregularity in your building, and then we have to respond to this structure accordingly. So in the E tab, following the path will give you the values that you can use in the design sheets. And if there is no torsion irregularity in your building, then you have to move towards the design. So we will check the diaphragm average and maximum drifts. We will check out the torsion irregularity sheet. We have to again insert the story data, story 1, 2, 3, and the load case, for example, the x, and the diaphragm in the x direction, and the average drift, maximum drift, and the ratios, and it will give you whether your structure is regular or irregular. So when there is irregularity, so what is the next step? We will talk about that. So we will delete these values and we will go to the E tab, and this time we will select the diaphragm average and maximum drift. We will filter only earthquake X. So you can copy all of these and insert in the Excel sheet, right? And it gives you a warning that your structure is irregular at the top, because at the top we have uh, overhead water tank, which is not considered in the calculation of the torsion irregularity and the drift. So you can ignore that story 11. And you can see that there is no irregularity in your building exists because the ratio is less than uh, 1.2. So when the ratio is greater than 1.2, for example, let me insert in here is 1.3. So it will give you uh, warning that your structure at this story is irregular, and if the ratio is greater than 1.4, so there is extreme irregularity, torsion irregularity in your building. So we will come towards the solution for the irregularity. We will check that in the y direction as well. uh, Unfilter the in y direction, and we will copy all of these, insert in here, and you can see that the story 1 is giving me irregularity of warning that you are stuck, because we can ignore the story 11 but we cannot ignore the story 1, right? The building is irregular at story 1. So what is the next solution for this problem when you have irregular story? The solution for this given by the code is, if the torsion irregularity in the building is greater than the limits, then you have to use this command, this equation, which is the amplification factor AX determined from this formula, and delta maximum divided by 1.2 times delta average whole square. So from this you will get a new factor. You can see this is the amplification factor which I've calculated from the average divided by the maximum divided by average into 2 times whole square. And after that you have to calculate the new accidental eccentricity, and it is calculated by multiplying the previous eccentricity you have used. In our case, you have to go to define load pattern, modify, click on this, and you can see the eccentricity we have used for all the diaphragm is 0.5, which is the 5%. You have to multiply this value with the calculated uh, amplification factor to get the new accidental eccentricity, right? So the new eccentricity has been calculated, and it comes out to be the maximum value, which is the 0.13, which is for the 10th story, but we have do not have any issue in the 10th story. So you can apply for the whole building the new eccentricity, or you can apply only for the story 1. For example, eccentricity overrides, you can select the story 1, and the eccentricity length you can calculate from the, you have to multiply the story length with the eccentricity in order to get the eccentricity length. right? And you can simply enter the new eccentricity in here in order to incorporate the new eccentricity in all the stories and click OK. After that, when you use the new eccentricity values, then there is no need to check again the torsion irregularity in the Excel sheet because you have already incorporated the torsion irregularity effect in the new eccentricity value. So this was the whole story about the module 7. So if you have any questions, you can ask.